Okay, so practice 2. Yesterday you had a chance to start on it in class already. So just check your answers over here. I don't think, if you need help for any part of the question, please raise your hand and let me know. Otherwise, just use this time, check the answers. Okay, as mentioned yesterday, the 2 over here, cancel it so that it becomes a 0. Then you put a 2 on its right hand side because we start with a smaller number first. Then the mode, 140 cm, median height, find the median position. So between 6 and number 7, the values are both 140, so the median is still 140. And it tells us that 25% of the students are taller than or equal to. So keyword over here, taller than or equal to. So we also include this value of x for the 25% of the people. So that's actually 3 students. Then we count the tallest 3 of them, 164, 150 and 152. So therefore x must be 152 cm because we are including that. Now practice 3. So check the answer over here. Range, simply largest minus the smallest. This 8 over here has has a blank. Okay, so there isn't an 80 something kilometer per hour. Largest is only 77. So part B, some context over there. There's a story behind it. If you are exceeding 63 kilometers per hour, you are over speeding. So exceeding 63 kilometers per hour means that 63 kilometers per hour is still okay. But if you go beyond that, more than 63 kilometers per hour, then you are speeding. So let us look for how many cars have a speed of more than 63 kilometers per hour. So we go 1, 2, 3, 4. There are 4 cars that have exceeded 63 kilometers per hour. So 4 out of 18 times 100%, you get 22 and 2.9%. Again, no need to round off. Do not leave in decimal, do not need to round off. Because this is an exact value. There is no reason to round off. Samuel, is that mathematics? I hope you're not doing my maths during other people's class also, huh? Okay, next. So construction of a stem and leaf diagram. Jermaine yesterday pointed out that there's an error over here. So as you check your work, just change this minute to, is this in grams? In grams, okay, so 75.0 grams. So you notice in this particular example, right, the stem and leaf diagram can be separated, or rather the stem and the leaf can be separated by a decimal point. I think this is the first instance that we see it in this set of notes. Usually they just attach the number from the leaf to the number in the stem. Today, they attach it also, but there's a decimal point in between. So when you are writing your key, okay, make sure the decimal is very clear. Okay? Don't make me wonder whether you actually intentionally wrote a decimal or you accidentally wrote it. Okay, then check the values, make sure you have a way of keeping track of which numbers were already written in your stem and leaf diagram. Okay, then the next one, constructing a stem and leaf, but we see a problem. All these stems, they have so many leaves. Okay, then it becomes very difficult to read. So one thing that we can do is actually to break it. Okay, it has very long leaves. You can break the stem into 2 parts. Break the stem into 2 parts. So one of the stem is from 0 to 4, the other stem is from 5 to 9. That's all there is to it. Okay, then same thing, we put a smaller number for the stem on top. We put a smaller number for the stem, for the leaves on the left hand side. So this is what it's going to look like. So many numbers. Okay, you can take some time to just copy this down, or just check your answers if you have already attempted it. Then of course you still must give a key. take note that for this key, in particular for this key, they used 0, 2. Okay, in earlier examples, we did not start off with a 0. It was always 14 or 2 or some other number. It was never 0 before. I think it's the first time you're seeing a 0. Doesn't change the way it works. 0, 2 just means 2. So these, the first 1, 2, 3, 4, 5, 6, 7. The first 7 leaves, they are just representing single digit for the length of the twigs. Okay, after the first 7, then we got 10 cm, 10 cm, 10 cm, 12 cm. Then we move on to comparing of data. Okay, 11.2D. Here we have defective light bulbs found in 12 boxes of 100 light bulbs. 12 boxes of 100 light bulbs. Let's take a moment to understand what that means. There are 12 boxes. Each box has 100 light bulbs. And there are 2 different factories. So this is called a back-to-back stem and leaf diagram. On one side, we have the leaves for factory A. On the other side, we have the leaves for factory B. You see that this is quite a neat way to combine data. So, of course, we only need to write the stem once. Instead of drawing 2 separate stem and leaf diagrams, instead of drawing 2 separate dot diagrams, or listing everything out, we combine everything over here. So you need to write the stem once. So on the left hand, you cover all this, then this is the stem and leaf diagram for factory A. Cover this is the stem and leaf diagram for factory B. Now, the presentation for factory B is what you have been using. What about for factory A? Doesn't make a difference. You read it the same way. 1, 4. So the number closest to the stem will be the smaller number. Okay, so it is like a mirror image on the other side. We put a smaller number closer to the stem for both A and B. They read it the same way. Okay, and in your key, use the format for right, R-I-G-H-T, hand, side, stem and leaf diagram. Yeah, lazy to spell. Use the right hand side format for stem and leaf diagram, which is what you have always been doing. Please don't try and write the key like this. And you tell me 9/1 means 19. Don't do that. Draw the key for the right hand side as usual. Okay, then once you get that done, the mode, the median is all the same. My concern is part B, which you guys appear to be copying now the answers already. Okay, which factory's production of light bulbs is better? Give a reason. This is write it down over here, performance. Question. This is a performance question. Means you look at a mean, median, or mode. So to determine mean, median, mode, you check what we have learned. Check, are there any outliers? No outliers over here, which means that we should use the mean. We should use the mean. But here's the little confusing part. Okay, I want you all to pause first. Just listen to me first before you just copy. Then when you revise, you don't know what's happening. Okay, just pause for a while first because I'm going to tell you something that you're going to find it contradicts what I have said before. It's going to sound like it contradicts. Okay, so you listen carefully. Normally, when we ask for performance, we check whether there is outlier. If there is outlier, you use the median. Otherwise, you use the mean, right? Because the mean takes into account everything. Now, in this case, there are no outliers. By right, we use the mean. Do you agree? Can you imagine calculating the mean for both of them? It's going to take some time, right? Because you need to add everything up very carefully. Then you do the division. If you do that correctly, you will not be faulted. You'll be okay. But here's the part that is a little confusing. Because in part A, we already found mode and median. then in part B, you can use either the mode or the median where applicable. Okay? Because in part B, the setter doesn't want you to spend all the time again calculating the mean. Okay? So in this case, since you have calculated the mode and the median already, you need to decide, should you use the mode or the median in this case? Which is a better measure of the central tendency, mode or median? Median, right? Because the context over here is that we're finding the number of light bulbs that are defective. So most of the time we'll either be using the mean or the median. They are kind of just as useful as each other, unless there's an outlier. But if there's no outlier and your data is presented this way, where in the previous part you have already found the mean or the median, you go ahead and use that for comparison. Okay, because typically about 1 mark only. For each comparison is about 1 mark only. So in this case, just compare the median. Okay, that's what they have done. So median for A, median for B, then you give an explanation. Okay, you write down the values, then you compare. Median of A is, that is the comparison. So you got the value, then you compare smaller than the other value. Then you have the conclusion. A is better as it has fewer defective light bulbs. Okay? So now, copy this out. Any questions? Any confusion must let me know. So notice on the left hand side, the notes is that you can compare using the mode, median or mean where applicable, when they are asking for performance. Where applicable, first choice is still the mean because there are no outliers. But part A already calculated the median, which is suitable as well. Not too bad, so use the median. But if you are talking about the range over here, then no, you don't get the point already. By the way, do you all know when to use the word fewer? So I cancel out lesser, right? Do you all know when to use the word fewer? Fewer versus less versus lesser. You know? When to use fewer? When you can count. Right? When you can count, you use fewer. Then when you use less? When you cannot count, like water. Yeah, okay, like water. Then when you use lesser? When do you use lesser? Lesser actually describes, it's not a measure for counting. You call somebody a lesser human being, that means you are saying that he's a lousy human being, for example. Okay, it's not used for counting. It's to insult somebody. You are a lesser being, you know, something like that. Okay, so you shouldn't be using the word lesser. Now practice 4. Here we have another back-to-back stem and leaf diagram. So we've got a leaves for school A, leaves for school B. Okay, then they tell us that 24% of the students in school A got distinction. So what's the minimum mark for a distinction? 24% of the students. So we need to find out how many students are there who got the distinction in school A. School A only, huh? So we start counting from the back. The largest number, which is 98. 1, 2, 3, 4, 5, 6. Oh, this guy. This is the cutoff. They got distinction. Okay, these are the people who got a distinction. And the minimum mark is 97. So minimum 97. and which school perform better. Okay, so in part B, I'll let you think about it. What would you use to determine which school did better for the exam? Will you use the mean, median, mode, or would you use something else? Can you make the decision? And then now we take a look at what is the suggested answer. Okay, so in part B, you can use the median. Again, you can use the median. So write down the two values for both median. Then this is a short form for writing median of A. So instead of writing median of school A equals to 86 marks, instead of writing that, we just write median and then put a little a at the bottom. So that's the lazy way of doing it. Median of A. Then you write down the value. This is 86 marks. Then I show you an even lazier way of writing the rest. Instead of writing higher than, write down, draw the inequality sign. Save some time, right? Median of A, which is 86 marks, is greater than median of B, which is 77 marks. Okay? Alternatively, you don't write equal, you also can draw brackets, which is 86 marks is greater than the median of B, which is 77 marks. This is fine also. So by writing it this way, you are stating the two values, you are showing me the comparison. Then all you need is one last statement for your conclusion. Therefore, school A performed better. And because in part A, you already looked at the percentage for the distinction for school A, you are also allowed to find out the percentage distinction for school B. That means find out how many people got 97 marks. So in school B, actually there are fewer, there are only 3 of them. So then your conclusion will be, still school A performed better because school A has 24% distinction, whereas school B has 3 out of 25 times 100%, which is 12%. Okay, or you can compare percentage distinction shown over here. Who needs more time? Okay, last question. Stem and leaf diagram. Masses of 30 apples, 25 bananas. So different numbers, Then write down the median mass of the apples. So you need to find the median position, which is between number 15 and number 16. Because the median position is 31 divided by 2, which is 15.5. So identify where is the number 15 and number 16. And it is important that you count carefully. Don't start counting at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They say, oh, this number 15, this number 16. Then wrong already. You must start counting from the smallest number. You have to count from the stem side. Closer to stem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? So between these two, we have 128 grams. 128 grams. Okay, find the range of the masses for the bananas is 44 grams. Find X. Okay, I'll let you try this first, because presentation will be a problem. Okay, 44 grams for the range of the bananas. How will you find X? How will you find X? The range is 44. Range is biggest minus smallest. Biggest minus smallest must be 44. Then how do you present your work? Doesn't solve it. How I'm going to be showing some of your work on the screen. All the interesting answers and presentation that I have. Okay. All of you have attempted it already. Correct me if I'm wrong. I say that x minus 103 equals to 44. Is this right? That means I say the range is equal to this. Is this correct? Yes. Yes, no. Then I continue to say that, therefore, x equals to 103 plus 44, which is 147 grams. Can I say this? No, huh? Why not? You look at the stem and leaf diagram carefully. X is a single digit. X is a leaf. X is not 1, 4 something. X is the something at the end of the 1, 4. Okay, so if you got this, then unfortunately, give yourself a little cross. It is not correct because there's a misconception. You are saying that you are thinking that X itself is the largest mass, which is not the case. X is a single digit. It is the last digit of the largest mass for the banana. Okay? So this one not correct. Then I show you some other presentations that your classmates did. What it could look like. Okay, so this one. So the range, this student is saying that the range 44 is equal to 140 plus x. Okay, why 140 plus x? He is trying to write down the largest mass of the banana. The largest mass is actually 14x, isn't it? 14x. So 14x is given by 140 plus x. Okay, so that's what this student is doing, 140 plus x, and then solve for x, which is 7. Which is okay. But don't copy it down yet. Then I've got another one. X itself has a value of 103 plus 44 minus 140. And then he got 7. What is happening over here? 103. Actually, I don't know what's happening over here. Okay, too lazy to think about it. But I think this student knows what he or she is doing. But I don't know what is happening over there. Okay. Next one, 140 plus x again. So similar to the first set that I showed you just now. Okay. So then, what is a suggested way of writing it? Okay, bosses are return the papers. Okay, so the suggested way of writing it, we say that the maximum value, okay, we find the maximum value first. Don't talk about x. The max value is 147. You all agree? You can find it from range, right? Maximum value. Okay, so instead of writing x over here, you say that this is the max. The range is given by the max minus 103, so the max is equal to 147. Okay, right now this is correct. Then you do a comparison. We notice very important over here, I did not say that 147 is equal to 14x. I did not say that because writing it this way means that it is 14 times x, which is not what our 147 represents. We are just doing a comparison over here. Okay, so what you can do is do it this way: 14 with a line and x. Then it is very clear. Oh, the x value must be 7. Okay, x is a digit, it is 7 in this case. So I think this is clear enough, or you can just write this down in this portion in pencil. In fact, you don't even need to write that portion out. You see 147 is the max, so you know that x is 7 already. You can straight write down the answer, x is 7. Okay, then we have the last part to it. Make two comparisons again. Performance, consistency. This is our performance. And this is our consistency. Then in our performance and consistency, state the value. Median apple 128 grams, greater than median banana, which is 125 grams. Therefore, apples are heavier than bananas. The next one, range, apples, stated value 67 grams, greater range, bananas, which is 44 grams. Therefore, mass of bananas more consistent. Okay, you can write down what is on the board instead of this also. This is the shortest already. Okay, I don't like to state that it's spread out or not. Use the word consistent in your explanation. So I'm giving you a new set of notes. Watch the video before your lesson tomorrow. I think think there are two videos inside. Histogram, basically kind of like a bar graph. Yes, need to do the textbook question. It is due. Today is Wednesday, right? It's due on Friday. Do you have lesson on Friday? Yes. Okay, due on Friday. Yes? Yes, Daniel? Okay, pass it down. Toss them. Thank you, class. Have a nice day.